Thank you, Dale. And for anybody who did happen to catch me at Stocker Day or Cattleman's Day, I promise I'll be more exciting. But there is a break after this, so if you need a nap, we're almost there. All right. I know it's getting hot. Sorry about that. And as Dale said, I am the sustainability guy in the department. Not really sure what that means. Outside of I drive a Subaru and I get to wear more flannels than the rest of the department. Other than that, I'm still kind of figuring it out. But mostly what I'm going to talk to you about today, and ignore the title. I was in a weird headspace. This seemed like it worked well in my office 4 months ago, and now I don't really like it. But what we're going to talk to you about today is new accounting methodology that's coming out. FAO just had a big announcement about it this week, and I'm going to tell you what that means for us, and heads up, it's good news, at least I think it is. And then we're going to talk through some research projects that we did, mostly in Oklahoma when I was there, but now some work we're doing at K-State as well. So just kind of like trying to baseline what our stocker producers are doing. You know, if we're managing for good performance, what does that do to our emissions? Right, so we'll kind of go through some of that. And in the middle, the reason I call this ecological niche is I'm going to present some data on historical versus current impacts on grazing ruminants in grasslands. It's a question I get all the time. It's like, hey, we had millions of head of bison here on the Great Plains. How much methane did they produce, and are we any different? And the good news is I'll have that answer for you today. All right, so where are we today as a society? Why do I get to go talk about emotional topics to students? Well, most of society is really focused in on climate change, right? Financial institutions, governing bodies, everybody's really worried about climate change, except that they're not really worried about climate change, they're worried about carbon dioxide emissions. We have hyper-focus as a society on carbon dioxide, and if we think of what sustainability actually is, or what we manage in a landscape, we manage for a lot more than just carbon dioxide, right? As a grazing sector, we provide a lot more than just meat and emissions, right? We take care of landscapes, we provide wildlife habitat, all that stuff gets lost in this discussion. And so after carbon dioxide, when it comes to cattle, people are worried about methane, except they're not worried about methane. They use a calculation to put it on carbon dioxide basis, so once again, they're worried about carbon dioxide. And the funny little thing about that conversion is it actually doesn't work at all. So they're just kind of looking at perhaps a direction change in energy. But as I'll talk about here in a second, it doesn't work at all. And if we look at emissions globally, why are people worried about carbon dioxide? Well, as a society, if you add in land use change and fossil fuel consumption, about 76% emissions globally come in the form of carbon dioxide. Methane, which is our primary greenhouse gas, clocks in at 18% globally. So for sure, as a society, we have a carbon dioxide problem. We take a lot of stored energy, we light it on fire to drive our cars, right? So most of our emissions are coming from CO2, and that's why people are worried about it. But my favorite part of this discussion today is it has resulted in climate anxiety, which I find very humorous. And I like to just read articles, such as the one at Denver University, where they're now teaching a class on how their students can better deal with climate anxiety. So this whole discussion on climate change has kind of gotten out of hand, in my opinion, but at least I have something funny to read and tell my students about, right? Because it's kind of a silly thing, or silly place we find ourselves at today. But if we ignore global emissions, because those are kind of useless, and look at US emissions, we also light a lot of CO2 on fire, right? So 79% of our emissions in the United States are coming in the form of carbon dioxide. Methane is just 12%. So a little bit different than the global numbers. And agriculture in the US is responsible for about 10% of our emissions by economic sector. And one thing to note is if you actually look at the EPA website, the global numbers are reported in agriculture, forestry, and other land use. If we were to report that the same way in the US, we would be a net sink. So why agriculture in the US is so heavily discussed in our role on climate is kind of beyond me. And then why they do choose to put a cow as the logo for agriculture on the EPA website is also a bit confusing, because 50% of agriculture's emissions are coming from soil, right, and not cattle. Cattle are beef cattle about 2% overall direct US emissions. So I always ask my students if they remember this saying from like the 90s, early 2000s, the kind of original sustainability saying, think global, act local. I'm not sure if anybody in here remembers that, or if maybe I'm just the weird one. But maybe don't do that with climate change if you want to develop practical solutions, right? Because things are very different depending on the country that you're in. Now, as I mentioned at the start, all these emissions are calculated on a carbon dioxide equivalent basis. And I'm just going to give you a quick rundown as to why we're starting to change how we calculate this. As I mentioned, it doesn't really work. So issues with global warming potential, that primary metric we use, when it comes to short-lived gas pollutants, it actually doesn't calculate their impact correctly. So it gives us a direction change. It doesn't tell us what their warming impact actually is. And then for long-term gases like carbon dioxide, which when they're emitted, they're basically there until they're not, it doesn't capture the irreversibility of those gases in the atmosphere, meaning it doesn't take into account the long-term impact on energy balance, right, which is unfortunate. The second point I wanted to make, and this is straight out of an atmospheric physicist publication, Pierre Humbert, global warming potential is actually not suitable for use on temperature targets. Unfortunately, we use this for temperature targets, right? So that, again, is the reason why it doesn't really work. And then lastly, using this GWP metric, it tells us that if we cut our methane emissions in the short term, we can buy ourselves time, and that's not actually how that works. If we cut methane emissions now, we still need to account for all those carbon dioxide emissions that we had previously. Right? We still need to pull that carbon out of the atmosphere. Our role would be sequestering that in the soil, right? So just a quick rundown. If somebody asks you if GWP works, just tell them no. And that guy at K-State who wears flannels and drives a Subaru said it didn't work. So the new metric that we have and what this means for us in the US and what it makes our impact look like if we treated methane as a short-lived gas pollutant or short-lived greenhouse gas. It's called GWP STAR. It was developed by some atmospheric physicists out of Oxford. I always like to throw that in when I'm in like a fancy meeting because I think it makes people believe it a little bit more than some guy at Kansas State who raises cows. But basically all they did was they made it a rate change, right? So methane's only in the atmosphere for 9 to 12 years before it's broken back down into CO2. Right, so they just accounted for that short-lived behavior in the atmosphere and then used the same coefficients as GWP to account for its actual warming impact. And to give you an example of why this is useful, we published a paper last year looking at US EPA data and FAO data and said, okay, what happens if we use GWP 100 and GWP STAR and we change our emission rates? Well, with GWP 100, we're always going to have a positive emission or impact on climate because it never leaves the atmosphere. Methane never leaves in that calculation. But with GWP STAR, a 0.32% decrease in our emissions as a cattle sector keeps us net neutral in terms of implied warming. And when I first started measuring methane on cattle some years ago, people were telling us you need to cut 80% of your emissions. Well, the new numbers, which are in the IPCC and all these European governing bodies, using this new stuff, just 0.32% reduction in emissions keeps us neutral. Anything beyond that means we are providing a, quote, cooling effect. And if we emit 1.01% increase in emissions year over year, that's the only point at which these two calculations are equal. So if anything, this number here is a lot more achievable, 0.32%, and I can just change my forage base 1 year and I'm going to capture that year over year, right? So if we look at GWP 100 versus GWP STAR, we recalculate all the US EPA greenhouse gas emissions, where does that put us? So looking at GWP 100, all enteric methane in the US, 26.9% of US methane emissions come in the form of enteric. That's the largest source in the United States of methane, and it's 2.9% of the total US greenhouse gas emissions. For beef, using this, we're 2.1% as an industry, so relatively small in comparison to, say, transportation. 73% of this is coming from the cow-calf sector, so most of our emissions are coming from the cow herd. I think that makes sense if we consider her the factory of our industry, right? She's out on grass mostly for an entire year, lower quality diet. Methane is essentially just an energy equation, right? It's an energy loss from the animal. So that's the primary emission source in cows using the traditional counting, 1.5% of US greenhouse gas. Stocker cattle, 0.3%, and finishing cattle are 0.27%. So all relatively small, but what happens when we recalculate this? And we use GWP star. Now, all of a sudden, all US enteric methane is just 0.76% of US greenhouse gas emissions. So very, very small. And beef only, so that's all three sectors, are 0.17% of greenhouse gas emissions. So most of this is due to changes in the US cow herd inventory. So we go back to 1990, which is kind of when these reports started, where they detail them really well post 1990, and we go through today. And if anybody was raising cows in the mid-90s, you might think about what our cow herd inventory looked like at that time, and it begins to make sense why we would have less emissions now because we got less cows, right? At least I know we went through a big herd reduction post 1995. So that's a large reason why this is changing, not necessarily management. But that's not to say that changes in herd size are the only way that we can make this happen, right? Changes in dietary quality, changes in supplementation strategies. These are all things that we already do a lot of, right? And just scaling those best management practices across the industry would mean that we can keep seeing this result over and over again. At least that's what our math is showing us. And then why should we care? Well, Cattlemen's Day, we had Dr. Jason Sawyer here, and he spoke pretty extensively on carbon markets, right? If anybody was there, really great talk. Dr. Sawyer is a really good scientist, kind of broke down carbon markets, right? I know I get calls all the time on this, mostly from Texas, because that's where I'm from. Sorry if you don't like Texas. But people want to know, hey, how can I make money doing this? Well, if we look at US beef production from 2010 to 2020, we are a net sink, or cooling effect from 2013 to 2016 using this new accounting method. So in my opinion, we should maybe be getting paid for that, or somebody should be getting paid for that. And if we apply this on a herd basis or an organization basis, I think we can provide an avenue for producers to get paid. And to me, it's not that far-fetched. Dr. Larson, if anybody knows Dr. Larson, her and I were just having a conversation about these kind of topics in the back. And this is the Wild West. Like, carbon markets are the Wild West. I don't understand them, and there's not that much oversight. So using the most up-to-date and accurate equations, to me, that makes sense. More sense than some of them anyway. And so we would like to see this get implemented across the US so people can get paid for their good management. A little funny artifact of this math was what happened to the dairy sector when we used this same equation. So if you look at our manure emissions, stayed pretty much the same, a little lower using the GWP star versus GWP 100. And then we found that for ruminant agriculture methane emissions, all of a sudden the warming impact of dairy manure was the largest source that we had year over year, right? So all of a sudden they look a lot worse, and I presented some of this at a dairy meeting, and I don't think they loved it, right? But it makes sense. The small dairies, they kind of have gone away over the last 30 years. Got a lot of friends in Michigan who are no longer in the dairy business because of that, right? We have a lot of large dairies, 20, 30,000 head, and they're managing all their manure in a slurry, right? That favors methane production. It creates those anaerobic conditions that favor its production. Plus, we've shifted some dietary fiber stuff in the dairy that have also resulted in this impact. But the good news is for the dairy folks, they seem to really like anaerobic digesters. Those things are starting to scale across the US, so they'll have solutions for this issue. And we're already seeing those digesters work really well in California because the California dairy industry has kind of got a good setup for getting payments for that. So we've seen an increase, but it's good because that's where we actually have solutions. Now, to the part where I called this presentation our ecological niche, right? Why did I call it that? Well, I often get asked, Great Plains had millions of bison. What happened to those bison, and why do we get credited with the mission, but those bison didn't, right? And that's fair. If we consider the role that ruminants play in an ecosystem, if we weren't grazing those ecosystems, something else would be there grazing them, right? And so what happens if we changed our baseline? Because all we did one day in 1990, we decided that agriculture was a human source of emissions. Beef cattle were a human source of emissions. They weren't natural, so any emissions they produce are unnatural emissions, right? Well, if we think about it, ruminants are a natural product of grassland ecosystems, and they're part of the natural carbon cycle, right? Everybody in here knows we graze cows or stockers out across our operations. They convert that forage into volatile fatty acids, microbial cell protein. They release a little bit of methane. The methane goes up in the atmosphere. Over 9 to 12 years, it's broken down back into CO2, and that CO2 is again available for uptake by plants, right? So a natural cycle that we have here. Well, just over 10 years ago, a professor at Penn State did a modeling exercise looking at the Great Plains bison herds, and he modeled a low bison population, a medium bison population, and a high population. And the medium population was probably pretty accurate for what was there. And he estimated their emissions using water buffalo as the method or the model behind it, all right? So somewhat similar, but probably not exactly. And you can see for low, he estimated 73.6 million metric tons of carbon dioxide emissions per year, up to 166 million metric tons of CO2 equivalent emissions per year. And in that year, 2007, I think was his basis for it, all ruminants were 134 million metric tons of emissions. So if this is our baseline for what was happening naturally on the Great Plains, and this is what we're doing now, at the very least, we're in the ballpark, right? We're in the ballpark of what was occurring naturally across our landscape. And to me, this deserves more of the, or to be told more to the general public, right? A more recent example, Pablo Manzano, a colleague of mine over in Spain, he did a modeling exercise in Africa. So he looked at the Serengeti ecosystem and the Lolando game control area where they have a bunch of agriculture. They're approximately the same size and total area. And he calculated the emissions from livestock in the game control area and then emissions from all wildlife on the Serengeti. And they were about the same, 76.5 kilograms of CO2 equivalents per unit area compared to 76.2 in the Serengeti. So this is the closest thing I've seen to like a modern estimate or comparison. I know it's Africa and it's not here, but same type of analysis and they get similar results. And I didn't put this in this publication, but if somebody comes back and says, well, you could look at the soil core record, right, or ice core record and get better estimates than these modeling exercises. Well, they did that. They've done that recently, and they looked at what happened to methane emissions as we exterminated bison on the Great Plains, mid-1800s, and their estimates are pretty much this, right in line with what Dr. Ristoff calculated them to be in our soil cores. So every direction people have approached this issue, we are emitting about the same as what would be occurring naturally, right? I know this is a long-winded speech on climate change, and I'm getting out of that now, but I just like to provide producers this information, so hopefully if somebody tries to argue with you, you can tell the story and provide the facts behind it. All right, so moving into our work, I fancy myself more of an expert on the grazing side. I don't really know why, because Zach and I have a feedlot study. I'm not really sure how I ended up with that. But most of my work to this point has been focused on grazing and looking at animal, soil, and plant interaction. So we looked at everything from how we move animals across the landscape, so rotational versus continuous grazing. And I'll give you some data on that. Choosing the right cow for our environment, and then supplementation strategies of stocker cattle on different forest systems. So how we kind of choose to go down different avenues when it comes to methane and grazing animals is we look at what strategies are viable and promising and what can be done by producers or is done by producers, and we just need to know the numbers behind it. So for methane mitigation strategies, they can be broken down into 3 categories. Dietary strategies, think of supplementing fats or supplementing energy on winter wheat, and we're going to talk about both of those. Rumen modifiers, like Bovair, which is about to come on the market, ionophores like Meninsin, and defaunination, and then increasing animal production. So for grazing systems, seaweed to me is probably not going to be viable, and if you ask me after this, I can tell you why. Bovair might be more focused on the dairy side or on the feedlot side at first. So oftentimes we are looking at management strategies and lipids, right? Those are areas where we've seen improvements in animal performance and improvements in methane emissions. So that's kind of where we're going to talk today. So the first study I'll talk about is one that we conducted in Oklahoma a few years ago. Ooh, I think I'm doing all right on time. Not sure when I started. But we looked at a dose response experiment feeding Oklahoma Green Gold, which is just an energy-based supplement, if anybody hasn't heard of it, to calves, so steers and heifers grazing winter wheat. We had a bit of a whoopsie on this as the project started, so we kind of had to re-rack, and that's why we got this weird treatment structure here. But we fed them from 0 to 5.5 pounds per feeding, and we did that every 3 days. So Monday, Wednesday, Friday is when we provided the supplement, and we balanced it by steers and heifers at each point. And here, this was the energy supplement we fed, so 62% ground corn, 21% wheat midds, and then Rumensin at 34 milligrams per kilogram. And if that number alarms you, my grad student, who was me, definitely formulated the ration wrong, and so we underfed Meninsin on this study. I'm sorry about that. That was a whoopsie on my part. And then, again, calves were fed every 3 days, and we used actual feed intake for the analysis of this study, and intake here peaked at 3 pounds per head per day. What we saw here was this ground corn supplement wasn't something that they wanted to consume a lot of. And our thought was that, this was an all right year for wheat. I think this was 2018 maybe, I'm not sure. All right year for wheat. But in this pasture, there was a lot of dormant native on the edges, and they seemed like they were going to get their energy sources there and weren't wanting too much of our supplement. They were kind of balancing themselves out a little naturally. So looking at animal performance and intake on this study, so looking over here with average daily gain versus total supplement intake. I'm sorry this is in kilos, but I couldn't make a good graph in pounds. This data is a little old and didn't translate over very well on my new computer. But this would be the higher end, 3 pounds per head per day. And average daily gain ranging from just over 8 kilos or 2 pounds up to 1.2 kilos on the high end. And we saw increasing but reducing relationship as we increase supplement intake. So at one point, right about here, 1.1 kilos per supplement, we weren't getting that same response in terms of average daily gain, but in general, supplementing did increase average daily gain. And looking at dry matter intake and total supplement intake, dry matter intake peaked at about 2 pounds of supplement intake per day and declined after that, so we started getting some substitution on that wheat pasture, which again made perfect sense to us because it was a pretty bad year for our wheat pastures. So made sense, and according to a lot of the extension literature at Oklahoma, it was kind of what we expected to see. And looking at emissions on this study, so again, this is a pretty common management strategy, feeding a little bit of extra energy on wheat. What happens to emissions? Well, looking at emission intensity or grams of methane per unit of gain, right? We had a pretty significant reduction as supplementation increased. So to me, this is a win-win for us, and it might be something that producers can capitalize on if somebody comes looking to sell you some carbon credits, say, well, I already have this strategy, and there's data in my region that says that I'm improving my carbon footprint, right? And then the last 2 studies from Oklahoma I'll talk about are supplementing fat, 2 different fat studies to Old World Blue Stem. I'll give you a heads up, this study was weird. The first one that I'm going to talk about, we've supplemented whole cottonseed. And prior to this study, we held these cattle over winter on the dormant pastures there and fed them a lot of salt for other purposes, and they didn't gain any weight. And so the first part of the summer, they gained a lot of weight, and it was pretty surprising for us. We were having to grease up the chute at the end of the study because they were gaining more than we anticipated. But for this study, we just looked at whole cottonseed. We didn't measure forage intake or anything like that. And we supplemented these steers 0, 2, 4, 6, 8, or 10 pounds per day of whole cottonseed. Nobody ate 10 pounds per head per day of whole cottonseed, so we used actual intake. And intake on this study plateaued at 5 pounds per head per day. But we decided to use whole cottonseed because it was cheap at the time, one of the cheapest energy sources or fat sources we could find. And then after this one, based on these results, we thought, what happens if we change the source of the fat? So we had whole cottonseed, and then we added in a supplement containing bypass fat. We used Megalac for that, and then a supplement containing soybean oil. And these supplements were formulated to provide the same amount of supplemental fat in the ration. But in actuality, we did have some small differences in fat concentrations here, which is just due to sourcing variability. And this would be the supplements that we provided. So we have a bait supplement that was the same for both studies, 97% soybean meal, 3% molasses, and then 100% whole cottonseed over here. And then for the second study, the same whole cottonseed treatment. Then the soybean oil treatment, or SBO, 73.3% cottonseed meal, 6% hulls, and then 20.7% soybean oil. And over here, the last treatment would be bypass fat, the one where we provided Megalac with the soybean or cottonseed meal and cottonseed hulls. So looking at these studies for animal performance, supplement intake on the x-axis here, average daily gain on the y. Supplementing whole cottonseed, we saw a linear increase in performance, which that part made sense to us because we're feeding them a whole bunch of energy, up to 5 pounds of extra energy per day. And for the other treatment, or the other study, looking at whole cottonseed, soybean oil, and bypass, all of those treatments had significantly higher average daily gain than the unsupplemented animals. And on this study, we did measure forage intake, and we saw a decrease in forage intake for those fat supplemented steers, which makes sense because fat can kind of bind up fiber in the rumen. That is at least our working hypothesis for reducing methane, is that it binds up fiber, but over 6% it can really shoot down dry matter intake. So we were expecting this, and when we added in the supplement intake, they were all balanced out at the end. And then looking at methane emissions, we saw pretty similar results between the two studies, but just looking at the whole cottonseed study first, supplement intake on the x-axis and methane, just absolute emissions on the y, had a quadratic response there, with methane emissions getting as low as 212 grams per day at the lowest. So good news there. And then emission intensity, which is again just grams of methane per unit of gain. We already saw that we had increased gain and lower emissions, so it makes sense that as we supplemented extra whole cottonseed, we had lower emission intensity for those calves as well. And then the emission results for the second study, we looked at methane grams per day, unit of gain, a unit of dry matter, and saw similar results. So whole cottonseed, soybean oil had significantly lower emissions than the whole cottonseed treatment, but interestingly, the bypass treatment had about the same amount of emissions as the control, which again should make sense if fat is serving to bind up fiber in the rumen, which it appears that it was when we look at the ADF digestibility, although NDF digestibility was about the same. And then emission intensity, similar to the previous study, emissions went down with the fat supplemented animals and the same with per unit of dry matter intake. So in general, fat supplementation really works to improve performance, and turns out it really works to reduce your emissions as well. And then I just have, I think, 2 more projects I'll tell you about, and then I can turn it over to your break and maybe nap time. I'm getting a little bit sweaty up here myself, but I am proud. I'm not wandering around too far. I have an issue with doing that sometimes. So I think I calmed down after the beginning. But one thing that we're really interested in is looking at how rotational grazing impacts emissions as well as animal performance. And I have a student here in the back who's working on this project right now, but we started this a few years ago down here in Alabama, looking at what they call AMP grazing now, or kind of in that savory management style, if you're familiar with it, versus continuous. And we have since moved that up to the northern Great Plains, so we're working in North Dakota and South Dakota right now. And the idea is just to move across the U.S. and figure out how do the management styles change our emission estimates, because the forages are much different here than they are here, right? The soils are different, animals are different. For one, I do not like the stalkers coming out of the southeast. Sorry if you run them, but my personal bias is I want to stay away from those a little bit. Up here, a lot more black-hided animals. In my experience, they do really well. So another thing we're looking at, grassland birds, soil, carbon sequestration, things like that, right? Also, people are pretty passionate about amp grazing. We were threatened this week by an amp grazer if our results didn't show what he wanted us to show, which was an interesting thing to happen. But looking at results from the southeast on enteric methane, we found that the amp cattle did emit significantly less methane than their continuous counterparts. And to us, visually on the landscapes, that kind of made sense because they were moving very quickly. They were keeping forage in a state of regrowth much longer. And so they just had higher quality diet relative to the continuous animals who were oftentimes being supplemented with hay at the time because their pastures were just pretty hammered and they were kind of in a drought. So it made sense to us to see this. Another thing I would say on one of these ranches was the cattle were probably BCSs of 2s and 3s. And for beef cows, that's not good. So that probably played a role in what we were seeing here, right? Another thing too on this amp side is one of it was the band Alabama. If anybody's familiar with the band Alabama, my students think I'm crazy when I talk about it, but that was pretty fun to go see their operation. Really cool people. And we look at soil carbon, because right now soil carbon sequestration is a big thing. We say, okay, how do the amp versus continuous compare in this respect? Well, this study has already been published by Samantha Mosier in 2021. What we found was that the adaptive multi-paddock or rotational grazing treatments had higher soil carbon stocks relative to the continuous group. And of interest to us was that it was actually this fraction here. The mound fraction is what we call it. So it's mineral associated organic matter. And why that is of interest is that that's the more stable fraction of organic matter in our soils. So potentially it's less susceptible to disturbance. And if we're increasing this fraction, we are going to increase the long-term holding capacity in our soils. So we were pretty excited to see that. But again, we're moving across the US going into soils where maybe it doesn't rain as much. Rains a lot in the southeast, doesn't rain so much here. So results could be pretty different. And then my last little piece, I think I'm good on time. Yes, I'm good. Working on cow size. This is of interest to me. For those of you who don't know, I like smaller cows, not too small, but I like smaller cows. Maybe that's because I grew up working in a lot of sale barns and was tired of messing with 1,800-pound tiger stripe cows that would come through the barn. So I just got a little bit of a bad taste in my mouth there. But why are we interested in that? So I think most people here probably know, but over the last half century, we have selected for a lot of growth, and specifically growth in the yard. And when we look at what's happened to our nation's cow herd over this time, we've seen a pretty significant increase. This is cow carcass weight from 1974 to 2022. So we went from just under 500 pounds of carcass weight up to 650. So that's a pretty big change, right? And if our producers aren't changing their stocking rate to correspond with those changes in dietary needs, it could, negatively impact the overall production of our system. One thing we did, and I know this is Michigan, but I'll just tell you, it responds very well to the work that was done in Kansas, Oklahoma, and Arkansas by Dr. Lawman. But we looked at data from 2011 to 2018 of our cow herd at the research center there in northern Michigan. We had 1,038 records, and we collected data on body weight, body condition, cow age at calving, calf body weight, or birth weight, calf weaning weight, 205-day adjusted weaning weight, forage quality, and then we calculated our carrying capacity looking at cow days per acre. And we adjusted all cows back to a body condition score of 5, and we said, okay, how much do these cows wean per year? How much do they wean per unit of land, wean per unit of body weight, and what's our economic returns for that? So sorry, this is blurry, but this is on a computer that I've been locked out of. I'm working on it. But this is every year looking at cow body weight on the X and weaning weight per unit of land on the Y. As cows got bigger, their weaning weight per unit of land decreased significantly. And, I took that slide out on accident. When we looked at the economic returns, same thing happened, right? So our larger cows here returned less money, both on a per cow basis and a per unit of land basis. We had maximum returns at about 1,050 to 1,100 pound cow was what was best for this system here. And then when we modeled this out over the full life cycle of that cow, so we did a net present value analysis looking at a 10-year cycle, we saw similar results that 1,100 pound cow best fit this system. And interestingly, when we started taking grazing days away from those lighter cows, the 950, 1,000, 1,100 pound cows, we actually got more money back through about 20 less grazing days. So that provided us a little bit of a cushion for, in Michigan it's late snow, but here it would be a drought, right? I'd be interested to redo some of this work in Kansas after we collect enough data on that. We're going to start on that this winter. We're going to be looking at, do these trends hold up for methane emissions? So this same data, if I look at methane emissions, because we had data from these cows, and just apply it to biological efficiency, which is percent of that cow's body weight that she weans every year, methane emissions per acre decreased significantly as cows were more efficient, and again, most of these are lighter. And methane emissions per 200-day grazing season, we saw a similar trend, right? But obviously, we need some more regionally specific data for that. I know Dr. Lahman's working on that at Oklahoma State. We're going to be working on that here starting this winter as well. Just trying to figure out, do these trends hold, right? And one concern that we do have, and I'm sure some of y'all might have, is, well, if we have, say a 1,000 pound cow, that calf's not going to be as valuable in the yard, right? So figuring out where the right weight is for this system, where we're also getting the performance that the rest of our industry desires further on through the production system. Because I think we're processing calves at 1,400 pounds right now, something like that. So we still need to meet market demands for carcass weight. So just trying to find the right balance there. I believe, yes, that is all of my presentation. Thank you. Any questions? Shoot them. Zach, are you thinking? Okay, that's bad for me. Oh goodness, all right.
So the last slide was, you said that smaller more calf weight.
There you go.
All right, nice job, Logan. I really enjoyed your talk, but then I got my brain rolling on those last two slides. So if you go back, was it cow? It was output of weaned calf per acre from smaller cows, but that stops at the ranch. So what does it look like if we apply that to the finished weight of the beef animal per cow per acre?
Yeah, so that kind of what I brought up there at the end is we need to do a better job of tracking this. And to my knowledge, there hasn't been too many people recently, but I know UNL has. And I think they were still getting smaller. They were processing smaller calves at the end of it. So you would have to put on a whole lot of extra weight for that smaller calf to produce the same yield, right? I think there's a balance that might shift that from 1,100 to say 1,250. Might be a better balance for the system as a whole, right? Does that make sense? Yeah.